When we look at New York City's greenhouse gas emissions profile, we see that around 65% of our greenhouse gas emissions comes from our existing building stock. So we know that improving the energy efficiency of our existing buildings is one of the most effective ways in which we can get to our greenhouse gas reduction targets. New York City has a commitment to reduce its greenhouse gas emissions 80% by 2050. So in 2007, we partnered with the city's 17 largest colleges and universities. The colleges and universities were the foundational group within the program. St. John's, being an early achiever of this 30% reduction goal in 2016, is now currently exploring what the next phase of the program will be with a deeper reduction in greenhouse gas emissions.
St. John's University has been on this path with New York City Carbon Challenge and making the commitment to reduce that 40% greenhouse gas reductions by the year 2030. In making such a commitment, there needed to be a roadmap. The roadmap became available primarily because of the funding from New York State reforming the energy vision in their technical assistance program to develop energy and greenhouse gas reduction roadmaps for colleges and universities in the state of New York. The benchmarking process takes the utility bills, takes the university square footage, and puts an energy unit to the square footage. It boils down to K, meaning thousands, K BTU per square foot of building space on the campus. Knowing where we are is a great start to be able to determine at the end how to get to more energy efficiencies.
So task one, the benchmarking effort, we found that the energy use intensity for St. John's University is essentially split 2/3 thermal and 1/3 electrical, with a total energy use intensity of 162 kBtu per square foot. This was partially due to the absorption chilling on the campus of St. John's and the steam plants operating at a lower efficiency than optimal with providing steam year-round to the campus. This was based upon data that we obtained through the utility bill tracking system.
The energy audit is really the investigation of all the mechanical systems on the campus. All of these can be reduced, and it's a matter of where we can make the reductions.
Task two, we did the energy audit for the campus of St. John's University. Knowing the benchmarking report and the results from that effort is being used to further understand where opportunities may reside. The law school at about 260 kBtu per square foot, St. John Hall at about 160 kBtu per square foot, and there were several buildings that were more reasonable and under 100 kBtu per square foot.
So what we found out is that through the benchmarking process and the energy audit process, there's a list of energy conservation measures. This list is quite long, and it has priorities that we can develop ourselves as things change over the years, but the priorities themselves will lead towards greenhouse gas reductions, energy conservation. The Energy Master Plan began with the thinking that if we can reduce our energy consumption and become as energy efficient as possible, then we can actually meet our commitment to the Mayor's Carbon Challenge and the New York State Reform the Energy Vision Campus Challenge.
Task three provided St. John's University facility staff a list of ECMs to consider in future new construction projects and renovation efforts. Task four was performing a heating plant life cycle cost analysis that included capital costs, operations and maintenance costs, including energy costs, appropriate escalators for energy over the 15-year period, and a discount rate that would be applicable to a college and university. The results showed that option one, upgrading the central boiler plants, had the lowest 15-year life cycle costs. Task five, energy management system. St. John's University employs 3 different energy management systems on their campus. We found several opportunities for improvement within the existing EMS. Task 6, submetering. During this effort, we looked at the existing campus electric and gas submetering in place on the campus of St. John's. So as projects are being implemented, it is recommended that an M&V plan is put in place to ensure that those projects meet their energy reduction targets. Task 7, energy procurement. Historically, St. John's University has used fixed price supply contracts for both electricity and natural gas. This has been good for their budgeting purposes and should be continued in the future. Although index pricing may provide some price breaks to the university, the monthly swings in the market volatility is not comfortable for the university. In the future, as energy projects get implemented for both electricity and natural gas, Antares recommends that they review the contract minimums to make sure that those current minimums are in line with their actual energy use patterns.
During the Energy Master Plan, we found out that auditing allows you to look at the financial and the energy and ways to bring it down. It could be as simple as pipe insulation, missing on pipes, to in-depth energy conservation measures as renewal and replacing the infrastructure of major mechanical equipment on campus.
Task 8, the implementation plan. Projects were provided in a priority order over the next 5 years through the year 2022 and would require significant engineering, construction, and coordination. The 5-year plan measures included 13 ECMs, reducing the thermal energy use intensity from 110 kBtu per square foot down to 66 kBtu per square foot, reducing energy use by 1 million therms per year and 1 million kilowatt hours per year with an estimated project cost of $10 million. The 10-year plan also included 14 additional ECMs, reducing the thermal energy use intensity down to 37 kBtu per square foot for an additional $10 million and provided 600,000 therms of annual energy savings and 3.5 million kilowatt hours of annual savings.
New York State has a program reforming the energy vision. This reforming the energy vision is very much in line with the New York City's carbon challenge. Both of the government agencies have long-term goals of reducing greenhouse gas emissions by 80% by the year 2050. Both agencies have interim goals of meeting the commitment to reduce the greenhouse gas by 40% by the year 2030. What I'd like our audience to be able to take away from the example of the St. John's University effort to take advantage of statewide technical assistance programs and to take examples from the New York City Carbon Challenge, bringing that into focus to find out what is achievable in energy efficiencies.